Hey everyone, I'm Sape42. Welcome to part 2 of my career mode science tutorial, Destination Moon. In part 1 we did our preparatory flight where we grabbed a few of the initial technologies. This will make our moon trip a little bit easier. Now we'll build the rocket, we'll fly it over to the moon, do a bunch of experiments there, and bring them all back to Kerbin. With the science we get here, we should be able to unlock a big chunk of the technology tree. So here's the technology tree as we left it from the last mission. So we've got general rocketry, stability, survivability, and science tech with the material science base. Okay, let's start building our moon rocket. So we've got some extra parts this time that we didn't have last time. One would be the batteries. That's going to help us out a lot. So our upper stage doesn't need to have the LVT-30 engine. We can just use a bunch of batteries. So we're going to use 2 symmetry for these. And we're going to be mixing symmetry in this. And that gets a little bit dangerous because if you're not in symmetry mode 1 and you pass your mouse over like a side part that has a different symmetry than the one you've selected, it will change to that symmetry. So 2 symmetry for the batteries, and we're going to use 4 symmetry for the science modules. So we have to be careful, and we'll have 4 symmetry for the goos, and keep those slightly above the engine so we can put our decoupler on there. And the science modules will give us, we'll use them for the wide base, and we'll put our landing gear on the sides of those. So now we're going to need parachutes, but we're only going to need 2 symmetry for these. So I'm taking care not to pass the mouse over the 4 symmetry items. So I did kind of a wide above the top kind of a pass. And put some nose cones on there. That's nice and aerodynamic. So this is going to get us from the moon back to Kerbin, so from the surface. So now we'll design the engine that's going to get us over to the moon. This is going to be kind of the workhorse stage. This has more. This stage actually will have probably the most delta V, except it doesn't have a high thrust to weight ratio. So we need to get this away from Kerbin before we light it up. So now we'll continue down and build the 2 stages that are going to get us into the like the upper atmosphere area. So we'll be using the 400 fuel tanks. We'll put 3 of these in a row, and all key copies things, remember, and then we'll use the LVT-45 engine. So we've got gimbaling on this, so we can steer ourselves as we're going up. So 6 symmetry, and we'll attach these outer fuel tanks to the bottom and make sure that they're slightly below that bottom one, so that the engines will hang a little below the center one to give it a nice base to stand on. So now that bottom point being the attachment point, it's going to give us a sturdy base. Those engines aren't going to make it flop around. However, when we build this the last stage on the bottom, we're going to continue down from the previous stage. So this whole the outer engines and fuel tanks are only going to have 1 attachment point. Now that is a problem, and we would definitely want struts under normal circumstances, but unfortunately we haven't unlocked them yet. And it's only going to pose minor problems. Sometimes the rocket still does shake, but it's kind of rare. So okay, the engines are slightly below the center. That was just verified that. I think that's going to wrap it up here. We know how to fix our staging. So we're going to combine the stages with the decouplers with the engines that will fire in the next stage. So 5 and 4, 3 and 2, 1 and 0. So we press the spacebar once, and we'll get a decoupling and the next stage firing, and then we want our parachutes to be in a stage all by themselves in in the very top. So looks good. Let's rename it. So moon rocket. All right, very original. All right, let's go. Save it and launch. All right, here we go. Now the top part bounced around a little bit on that decoupler, but it seems pretty stable. It doesn't seem to be wobbling around. That's good. Okay, so we're ready. Shift will throttle up, hit the SAS with the T key, and spacebar as we lift off. So this liftoff, not much is going to happen. We're just going to go straight up till we get to 10,000 meters, and then we're going to head east. So now I get to talk a little bit about the quirks of this rocket. So this is normally a stable rocket, but there are some times when it'll just start wiggling. It hasn't happened since the new NASA asteroid patch, but that doesn't mean it won't happen. So generally, like maybe 4 out of 5 times I'm okay, but you never know when that's going to happen. If it does happen, you can just revert back to the launch. But on launch, since we got those LVT-45 engines, we should be able to, like the SAS should be able to correct for any like steering issues. There is one thing about spinning though, because when we turn, okay, so that was the first stage. Spacebar separates the second stage, and this stage should get us most of the way to the upper atmosphere. So when we're about to turn, the thing is going to start rotating. It usually does, and sometimes the SAS can correct for it. It's like the SAS can correct for it, but it doesn't sometimes. I don't know why. Sometimes it does, sometimes it doesn't. So hopefully we'll get lucky. If it somehow doesn't, and you can just get it to like the 45 degree, the 45 and the 90 kind of cross on the nav ball, and just hold it there, let it spin. When you eject the second stage, the third stage should be fine. So we just hit 10,000. Now we're turning over, so you can see. Actually, we're doing okay, and we're just gonna hold it here. So if you're able to get it here, you can just let it go, and we're gonna burn this entire stage out, situated at this like 45 degree vertical line, heading east on the 90 degree. Is that the longitude or the latitude? I don't remember which one it is. So here we go, we're almost there. So our experiments, we're taking 4 experiments with us. So we can do this one of 2 ways. One would be we take an experiment when we're high above the moon, and then another one when we're close to the moon, and then we do 2 once we're on the ground. So here we go. So now we separate the stages, and after this I'm going to rotate and follow the nav ball. Now turning is much simpler since we don't have a big rocket that we're lugging around. And for this, I'm going to go up to about 100,000 meters, but I'm going to set up a maneuver node here. If you find out that it's not enough time, you can always bring it out to 150,000. So I'll continue talking about the experiments in a moment. So we reached 100, we hit X, we killed the throttle, and now we'll add a maneuver here, and we'll just fire prograde until we get circular. That's going to be our goal here. So a little too far. Go back until like apoaps and periops are kind of on opposite sides of each other. Alright, good. And that's going to take 1,000 delta V or so. This stage has got about 3,000 delta V in it, so it should be able to get us into orbit, then get us over to the moon, and slow us down enough to actually land. And then the final stage will do the actual landing. So here we go. We'll face the little blue waypoint indicator in our nav ball. Accelerate time. So we're going to split this half and half. So we'll wait till the node is about half of what the burn time is. and node T minus 40 or so, and omit at 30. So it's roughly half. And then we'll just burn this until we finish this waypoint. So go back to talking about the experiments. So one of the ways we'll do, because we got four experiments, but there's really only 3 places to take an experiment. There's above the moon, or high above the moon, near the moon, and then when we get onto the surface. So what I'm going to do is actually double up the experiments, because I'm going to max out the science that I'm going to get. So we'll take 2 experiments high above the moon, and then I'll totally skip over near the moon, and I'll land on the surface, and we'll get 2 experiments on the surface. So the idea is we're going to do 2 moon missions, and we'll get a lot more science that way. So the first one we'll get high above the moon and on the ground, and the second one we'll get near the moon and then on a different place on the ground, because the moon has a bunch of different biomes that you can land on and do science at. Alright, so we are approaching the destination, and I'm gonna stop it. That's about good. It's not perfect, but we don't need it to be exactly circular. So now we need to, alright, it's 194. We need to select the moon as a target, and then we'll be able to see the node. So if we did a good job, and it looks like we did, we only have a 0.2% inclination, but I'm going to go through the motions anyway, and I'll null these out. So I'll create a waypoint or a maneuver node at the node, and I will, since it was a descending node, I'm going to ascend, and I will accelerate time to get over there. So if I were to mess up, let's say my rocket were spinning and I wasn't able to keep it on the 90 degree, I would have more of an offset, and this is where you can waste a lot of fuel. Like if you're probably more than 5 degrees off, that's a lot of fuel to straighten out. So hopefully you can stay within that. If you're able to keep it on that 90 degree though, you should be fine. So right now I need to find that waypoint. It looks like I went to the wrong side. So I'm looking for, since this was a descending node, we're going to ascend, which means you need to point straight up. And that is where that little orange north line on the nav ball meets the white one. So you can see I'm sort of aligned heading up. And there we go. That's probably good. And we got 0.0. You probably could even neglect that if it's below 0.5 and you still be able to get a perfectly good encounter with the moon. So now I'm going to set up a new maneuver node, sort of like I'm going to go sideways, and I'm almost there. So I'm going to take the center part of the maneuver node and rotate it around to line it up properly. And we're shooting for a periapse of around 100,000 on the moon. A moon periapse, okay, that's close enough. Around 100,000. Doesn't need to be exact. So now we've got it. We're going to align with the waypoint, and we'll start our burn. Actually, no, not yet. We're going to accelerate time first. Yeah, if we burned now, bad things would happen. Alright, so accelerate time, and we're going to try to split this the same way we did before. We'll make the node time equal to about half of the burn time. So one thing that I've noticed is you can't really trust the estimated burn time all the time. So what I normally do is I get close to where I'm going to go. So the time, I still have more time left, and I do a burn to full throttle, and then I'll cut my engine. So if I go to full throttle, it gives me the proper estimated time of the burn. So sometimes you get like a 2-second burn, you know it's going to take longer than 2 seconds, and so it's not calculating right. Okay, so here we go. We accelerated a little bit, and there we go. So, you know, maybe this happens when, if you're not at full throttle, when you cut the engines, it will predict from wherever you were before. But that can really mess me up. So anyway, so I usually will get close to where I got a little time left, and then I'll go full throttle and then back off the engines, and then I'll have an accurate representation of how much time it's actually going to take. All right, so our strategy is going to be, we're going to get a moon encounter, and then we're going to set our periaps to about 100,000 meters, and then we'll accelerate time, we'll get over there, and we'll do a retrograde burn at the periaps to circularize our orbit. And then since we don't have any landing lights, we'll try to land in the light. Okay, so here I stopped my burn a little bit early, just so that I can manually see the rest of it. Okay, so here we go, a little bit more. If you happen to overshoot this, you can always turn yourself around to point prograde on the nav ball, and then do retrograde. We're facing prograde now, so if you do a retrograde burn, you'll reduce you'll make your periaps bigger, so you can fine-tune it that way in case you overshoot. So here we go, we're time warping away, heading towards the moon. And there it is, here we come. Oh yeah, experiments. We're gonna need to do a high over the moon experiment as soon as we get capture. And here's another spot to be careful about. If you go into this encounter, so that little circle is where we're gonna encounter the moon. If we hit that going too fast, it can mess up your periaps. Although you set it for a certain number, it can get messed up if you go too fast, and it'll be a different number, and then you don't realize and you crash into the moon. So let's do our experiments. So material, we're going to observe materials, and I'm going to do 2 here. So we got high over the moon, that's good. 2 high over the moon, and save those, and then we'll do 2 goos as well, same thing. Keep the data. And as we get closer to the moon, we get more science. And so let's get a crew report, and we'll transmit this. So we've got our batteries, and we should be able to transmit just about everything without having to worry about it. And I'll take Jebediah out on an EVA, do an EVA report, and keep that, and then we'll go back into the capsule. And now save it. Yeah, definitely. I think I forgot to save it up to this point. So time warp close, we're going to go head to the periaps, and once we get there, we're going to face retrograde, and then we'll just burn until we circularize. So I'm not going to bother with setting up a maneuver node. The moon it doesn't take that much thrust in order to circularize, and it doesn't need to be perfectly circular, as long as we get something that's close. So we're pointing retrograde now, and we'll start our burn, and let's watch. Throttle up a little bit, and here we go, and coming down. 4, 3, 2, 1, and we're circular. So pretty good. All right. So the way we're going to do this is we're going to land in a crater first of all, because that's pretty much all the craters are at least one biome. So for the 2 missions, one would be a crater, one could be like outside of a crater. The crater's a little harder to hit than the outside. So the way that I am going to do this is I'm going to set up for where I'm going to land from the opposite side of the point that I want to land at. So here I am. I want to land in that crater that's facing us. And so I start from the opposite side, and then I'm going to point retrograde, and I'm going to do a burn, and I'm going to reduce the periaps so that it's just above the opposite side. And since I'm near circular, you can pretty much do this maneuver from any point, since all points are relatively equal. So I'm going to lower the periaps so it's just above the spot on the land that I want to actually touch down. So what we're going to be doing is skimming over the surface. So I'm going to lower this. I'd like to lower it so that it's like, 10 meters above the ground, but I'm going to go to about 6,000 meters. There we go. And so we'll skim across that little spot. If I made it any less, I'd be in danger of hitting the little ridges there that are kind of surrounding the crater. So there we go. Now this is okay, we got to make sure you save it. This is a great spot to practice landings. So if you can land on the moon well, like this, you can pretty much land anywhere. Since the higher gravity worlds, like if you're trying to land on like Tylo, for instance, or even on Kerbin, if you if you don't have parachutes or something, you can. It's the exact same technique. It's just a little bit quicker. Your response time has to be a little more. So here we go. We're coming down to the surface, and I press the V key to change my view to free, so I can kind of get a horizontal view of the ground. So accelerating time a little bit. This rocket has quite a bit of acceleration, so when we see our landing spot, we can almost be right over it and still be able to hit it. So actually, here's something that I didn't do. I need to rotate myself around so that I'm pointing retrogrades. You don't want to miss our landing spot. So yeah, maybe if you were doing this, you would rotate around before you got to this point. I'm kind of doing this last minute, and then I'm gonna try to make the sky. All right, so we're over the crater now, and the way that I'm going to descend, I'm rotating to try to make the sky to be up. This is totally not necessary, but I'm gonna get down to around 100 meters per second, and then I'm going to slowly reduce the throttle. So the retrograde vector, we want that to be at the very top of the blue part of the nav ball. So that means we're going to be coming straight down. So I'm keeping it around 60, and I'm letting the retrograde vector kind of go up towards the top. So eventually I'm going to put my heading right on the retrograde, but I'm keeping it a little below the vector. It's kind of like pushing it up, and I'm keeping the throttle low. I don't want to slow down too much. So I'm only going 36, going around maybe 40 at this altitude. 40 meters per second is good. So now the retrograde vector's straight vertical, and now I'll align my nose towards it. So now if I hold this position, I'll come straight down, and all I have to do is I worry about the keeping the retrograde vector on the center, and then watching my speed. So as I'm coming down, I'm going to throttle up a little bit more, keep the speed going, slowing down slowly, and as the retrograde vector moves off, I kind of have to go past it a little bit to push it back on center. So this technique works pretty well if you're just for pretty much any body that you land on. The problem I'm having right now is that there's still fuel left in this last stage, and so I'm going to need to drop this stage, but I want to have time to do the landing gear. So I'm accelerating beyond, and then I'll eject the stage. So I'm actually going up right now. It gives me more time to react and kill the throttle and then start the next stage. So I'm going to do the same thing. I'm going to hit the G key, drop the gear. So I'm keeping my eye, and there goes the other exploding stages. So keeping the throttle, slowing down, trying to keep the retrograde vector on the middle, and we touched down. Okay, so there we go. We finally made it. So this was actually a pretty efficient landing. I have most of my fuel in these tanks. Now, you don't need to have it like that. You could, as long as you've got like a little bit more than half of the fuel left, you can possibly make it back. So we'll transmit a crew report here, and now we're going to do some materials bay observations. And look at that, recovery 100, science. That's awesome. We'll keep those, and we'll do our goo observations. There we go, keep those. And then we'll take Jebediah out for an EVA report. Now, the same little quirk happens here that it did on the launch pad. If you do an EVA report while holding the ladder, it says from space just above the biome that you're at. So I'll enter, and then I'll take him out again, and we'll go down actually to the surface. So let go, and then we'll turn around. What's happening? We're being pulled into the capsule. Oh no, don't break. That was very strange. Okay, let's jetpack off. So the R key will engage the jetpack, and then you just use the WASD and Shift and Control keys. And we'll remove the jetpack. Look at that. That is one happy Kerbal. So let's take a surface sample, and we'll do an EVA report. And of course, we're going to have to plant a flag. I mean, how can you get all the way to the moon and not plant the flag? That is just awesome. Okay. So this little landing sequence is a great way to work on your piloting skills. Get that finger dexterity up. You can do a quick save before the land, and then quick load it and go through it a couple times. There's a lot happening in that short little period of time. So now let's head back. So engage the jetpack, and we'll make our way back over to the capsule. There we go, slow and steady. There's another way to work on your piloting skills, do a lot of EVA stuff. So let's grab and board. So we're going to launch this the same way that we did, sort of like as we're preparing our gravity turn from Kerbin. We're going to head 90 degrees. We're going to find the 90, and there it is. It looks like it's up from us, and then we're going to throttle up. Let's check our resources. Throttle up, and then head to the 90, where the 90 and the 45 meet. So we're going to go east again, and raise the gear, and we'll keep it throttled up full till we get maybe 300 or so meters per second. And this is much easier than leaving Kerbin. You can coast for a long time and set up maneuver nodes and not have to worry about missing it. And the thrust to weight ratio is very big on here. So here we go. 30,000. I'm going to take it up to about 70,000 meters. If you're low on fuel, you might want to stay closer to like 25,000. So there we go, 70, 73. And then we will add a maneuver node to circularize. This is somewhat important for the step that we're about to do. So accelerate time. So I'm going to try to eject myself from the moon and keep the momentum that I'm ejecting with to slow myself down in Kerbin's orbit. Kind of like killing two birds with one stone. So pointing at our waypoint, and then throttle up. So it doesn't take that much to circularize this one. Less than 200 meters per second. So here we go. So I'm going to use my ejection velocity to slow down my orbit from Kerbin, and then that'll save a little bit of fuel. So the way that I'm going to do this, first I have to find out where Kerbin is. And I'm orbiting, that'd be counterclockwise. So add a maneuver, and it's about maybe 90 degrees or so. So I'll click on the periapse and it'll stay there. So I'll move the prograde and as well as move the node around to try to find where the Kerbin periapse is the lowest. And as I burn faster, the angle that I eject from the moon is going to change a little bit. So it kind of requires going back and forth. Notice that the periapse has disappeared now. So that means I am going to, if I do this exact burn, when I leave the moon, I'll swing around and then come into Kerbin's atmosphere as well and be able to land without having to do any adjustments. So now we'll time warp around to where we're closer to where we're gonna do our burn. So this actually will minimize the what's called gravity losses, because as I am leaving the moon's influence, it's still pulling on me, so it'll be slowing me down a little bit. So the faster I eject out of the moon's atmosphere, I'm sorry, not atmosphere, the moon's gravity, the less it'll be able to act on me. So I'm going to try to do the entire, if I do this entire burn in one shot, and I eject quicker, the gravity losses will be less, and then overall I'll save fuel. So for the moon, it's probably not going to save me too much, but if you're going to other planets and you're trying to eject from Kerbin, that will save you quite a bit. So now I'm just going to do this last little bit manually until it just disappears. Now we really didn't need to make the periapse disappear. If it were like 20,000 or so, we would spend a lot more time in the atmosphere, and that's more ideal if you're coming in from another planet and you've got a lot of velocity coming into Kerbin's influence, and if you don't bleed some of that off, you can just smack right into the planet without having time to slow down. But in this case, it's not too important. We're not going straight into the ground. We're gonna graze it like we did before, and luckily we're gonna land in the light. Also not necessary, but you know, for a video, landing in the light is better, preferable, so that you can see what's going on, to landing in the dark. Alright, so we're now in the atmosphere. We'll hit the thick of the atmosphere at around 30,000 meters, and that's when the fire will start. So we'll speed up time a little bit, because this is just kind of a lot of waiting around. So there we go. I've disengaged my SAS, and now I'm kind of wobbling around the stable point. So it's stable in reverse, and that's good, because when we throw out our parachutes, we don't want it to be whipping around. So we can pretty much deploy the parachutes anytime, but I'll just wait till it slows down a little bit more. And always take yourself out of time warp when you do the parachutes, just because of the physics. And then when the parachutes are about to open, you want to go out of time warp again, make sure it's back on time warp 1, so that the spacecraft doesn't break apart. Okay, so we did okay. And parachutes are open, nothing broke, that's great. But there is one issue. If you notice the speed, it's above 6 meters per second. Now some of these items on here have a crash tolerance of 6 meters per second. So what I'm going to do is I'm going to get right above the water, and then I'm going to put on my engines just slightly. I want to get below 6. And of course, landing in the water should be easier than landing on land. Okay, there I am. I'm just below 6. I should be okay. So now we hit the water, we hit X, kill the throttle, And we are back home. Great, so let's recover this. And now we've got a successful mission. Alright, 573 science. That's including the transmitting ones. I guess we brought back 529.4 from all the missions that we did. So just to go back to that landing in the water. Now you'd think landing in the water would be easier than landing on land, but for some reason the crash tolerance still applies. So on land you might be able to take more than that because you got your landing gear, but in the water it doesn't slow you down that much, and the parts that touch the water, if they touch the water at their crash tolerance or above, they will explode or they'll disappear or something. So best to either put more parachutes on or use just a little bit of throttle to slow down your ascent or your descent. So that will wrap up this mission. I hope you all enjoyed it, and stay tuned. Next time we'll be going to Duna. Alright, take care.